Hello, my name is Nicolas. I'm a student at UniLasalle at Amiens.
Hello everyone, I am Chiri Chawe. I'm a third year student at UniLasalle Amiens. We are here today to present our electronic project with a robot who has the possibility of moving on its own.
I will now explain the design aspect of the robot. I will present the materials we used. We used an Arduino Nano board, which powers the robot by allowing us to upload the Arduino code to the device. We also used 3 sensors that detect if an obstacle is too close to the robot, allowing it to turn at the right moment. We placed the sensor at the front of the robot, as well as the L pins of the sensors to pin A5 on the Arduino board. Finally, we connected the GPLO pins of the sensor to pin day 4, day 5, and day 6. This allowed us to differentiate between the 3 sensors when we write the code.
Our robot is designed to move autonomously throughout a maze. To do this, we use 3 distance sensors and 2 servo motors controlled by an Arduino program. The sensors allow the robot to detect walls around it, and the servos control the wheels for movement. 1. Sensor system. We use the Adafruit VE6 1H80X sensors. 1 on the right, 1 in the center, and 1 on the left. Each sensor measures the distance between the robot and the walls. This information helps the robot decide whether to move forward, turn, or adjust its positions. 2. Servo motors. The robot has 2 sensor motors, 1 for the left wheels and 1 for the right wheels. By controlling the speed and direction, we can make the robot to go forward, turn left or right, or stop. 3. Navigation logic. The program follows a wall-following algorithm mainly based on the right-hand rule. Here's how it works. 1. If there are walls in front, the robot turns left to avoid it. 2. If they are right or is too far, the robot turns slightly right to get closer. 3. If the right row is too close, it turns slightly left to move away. 4. If the distance is perfect, it moves straight ahead. This way, the robot can navigate throughout a maze while keeping a safe distance from the walls. 4. Calibration and movement. We also define some parameters like 1. The ideal distance from the right was about 16 minutes. The obstacle detection distance 50 mm, and the turning duration for a 19-degree turn. These parameters can be adjusted depending on the maze of the robot's speed. 5. Conclusion. To summarize this, This program gives our robot the ability to sense its environment using the 3 sensors, decide how to move based on distance measurements, and act using the servo motor to move and turn.
In this video, we can explain the method of which we have created our robot and the problem we met.
Thank you for listening to us. We appreciate the time you have given us, and if you have any questions or comments, please feel free to leave them below. Goodbye.
Goodbye.